This is the third video of carbon and its compounds, and in this video we are going to discuss combustion reactions, oxidation reactions, addition reactions and substitution reactions. Let's start with combustion reactions. What are combustion reactions? Combustion reactions are those reactions in which a substance is burned in presence of oxygen. All such reactions are called combustion reactions. Particularly now we are going to discuss combustion reactions of carbon compounds. So the simplest one is carbon, that is coal, burns in presence of oxygen, gives carbon dioxide. In all combustion reactions, heat and light will be emitted. Heat will be released and light will be emitted. So all combustion reactions are exothermic reactions. And moreover, all combustion reactions takes place in the presence of oxygen. Without oxygen, there is no combustion. So combustion reactions are also oxidation reactions. Here few examples I have given. When carbon combines with oxygen, carbon dioxide will be formed along with the emission of heat and light. Similarly, when methane is burnt, it gives carbon dioxide and water, heat and light. Here this reaction is not balanced. Similarly, when ethanol is burnt in oxygen, carbon dioxide and water will be formed along with heat and light. These two reactions are not balanced. Let's see how to balance these reactions. Generally, when hydrocarbons are burnt in oxygen, the common products are carbon dioxide and water. Carbon dioxide and water are the common products. So here the number of carbon dioxide molecules formed will be equal to number of carbon atoms present. See here, in the first equation, one carbon atom is there, so one carbon dioxide molecule is formed, so this is balanced. And number of water molecules will be formed should be equal to the half of the number of hydrogen atoms. Here there are 4 hydrogen atoms, so number of water molecules should be half of this. That means 2 water molecules should be formed. So here we have to multiply this with 2. Number of water molecules will be half of the number of hydrogen atoms. Since there are 4 hydrogen atoms, number of water molecules should be 2. And finally, we need to balance number of oxygen atoms. Now first count the number of oxygen atoms in the product side. Here 2 oxygens and here also 2 oxygens. Total 4 oxygens are there in the product side. So in the reactant side also should be 4 oxygens. But here already O2, 2 oxygens are there. To balance this, we have to multiply with 2. Then automatically reaction is balanced. The same process we will follow for any hydrocarbon under combustion. Right? And during combustion, we might observe few compounds burn with flame, few compounds do not burn with flame. What is the reason? For example, when you burn LPG or candle or wood and it burns with flame, few compounds do not burn with flame. For example, coal. Coal do not give flame, but it just burns. But initially it gives little bit flame. What is the reason? The main reason for this is when a substance converted to gas, then it gives flame. If the substance does not convert it to gas, then it doesn't give flame. So that's why coal doesn't give flame, because it doesn't convert into gaseous substance. Color of the flame is the characteristic property of a particular element. Generally in inorganic chemistry, we will identify certain elements by the color of the flame. For example, lithium on flame test gives a crimson red color, whereas a sodium gives a bright yellow color, potassium gives purple color, and magnesium gives no color, that is white and colorless. Calcium gives orange red, strontium gives bright red. Next, how coal and petroleum are formed. Coal and petroleum are formed from the remains of dead plants and marine organisms. When they undergo very high pressure and high heat over the millions of years under the earth or under the sea, and they converted into coal and petroleum respectively. Next chemical property, oxidation reactions. In oxidation reactions of organic compounds, we use certain oxidizing agents. Here the best oxidizing agents that we use are alkaline potassium permanganate or acidified potassium dichromate. These are the best oxidizing agents. Here we will discuss about one equation that's given in our textbook, that is ethanol, CH3 CH2 OH. Ethanol, this is an alcohol. Already we have discussed in the previous video. This is alcohol. When it undergoes oxidation in the presence of oxidizing agent, here some oxidation reaction takes place. What happens during this oxidation? You might have studied about oxidation in the previous chapters. So what is oxidation? Oxidation means addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen is called oxidation. So both process takes place here. So here you do one thing, remove this hydrogen. Removal of hydrogen is oxidation, and in the place of this hydrogen you add one oxygen. Then that means simply CH3 CH2OH. Here this hydrogen you replace with oxygen, then you will get CH3 COOH. That means in the place of H2 we have substituted oxygen and it is converted to CH3COOH. This is ethanoic acid. This is COOH is carboxylic acid. Ethanoic acid will be formed. This is the simplest example for oxidation reaction. Next, third one, addition reactions. Generally unsaturated hydrocarbons like alkenes and alkynes undergo addition reactions. During addition reactions, these unsaturated hydrocarbons converted to saturated hydrocarbons. Very details and with many more examples you will study in higher classes. Here we are going to discuss very simple example of addition reaction. Here I have taken one alkene, C double bond C, here R. Here R represents an alkyl group, or simply you can take in the place of R you can use H also, no problem. And this is the simplest example. If you use H, this becomes CH2, this becomes CH2, CH2, CH2. Here two carbons are there, so root word is eth, double bond is there, ethene. Suppose in the place of R, if you take H, it becomes ethene. This is an unsaturated hydrocarbon. It undergo addition reaction. What happens during addition reaction? Here two hydrogen atoms are there. This is called hydrogenation reaction. Generally, these hydrogenation reactions takes place in the presence of catalyst nickel. In the presence of catalyst, it undergoes hydrogenation. Here two hydrogens are there now. One hydrogen you add at one carbon, that is first carbon, and you add the second hydrogen at second carbon. When you are adding hydrogens at alternate carbon atoms, that is double bonded carbon atoms, simultaneously you have to break this bond. There is a double bond, no? You have to break one bond. What is the need of breaking bond? If you don't break the bond, the valency of carbon becomes 5. Actually the valency of carbon is 4. To satisfy the valency of carbon, we have to break one bond, that is a pi bond between carbon and carbon. So then it becomes, see here, C, earlier there was no H here, so here we have added one H, and this carbon also has got one H, and this double bond becomes single bond. Here these are alkyl groups, R means alkyl group, otherwise here I told you to take hydrogen in the place of R so that you can easily remember. This becomes a CH3, 3 hydrogens are there. This becomes CH3, 3 hydrogens are there. Suppose if both are 3 hydrogens, then it becomes CH3 bond CH3, and name of this compound is ethane. Eth, 2 carbons, and all are single bonds, so it is a family of alkanes. We'll get ethane. That means ethene converted to ethane, alkene converted to alkane. That means during addition reactions, unsaturated hydrocarbons converted to saturated hydrocarbons. In general, addition reactions takes place in presence of catalyst. For example, this is a hydrogenation reaction. Hydrogenation reactions takes place in the presence of nickel catalyst. You know the best example for hydrogenation reaction? The best example for hydrogenation reaction is conversion of vegetable oils into dalda. Dalda is also called artificial ghee. This is the simplest example for that conversion. And vegetable oils have unsaturated fatty acids. Those are considered to be healthy. Whereas animal fat has saturated fatty acids, that is unhealthy. Next, last one, substitution reactions. As we discussed in addition reactions will be taken place in unsaturated hydrocarbons, but whereas substitution reactions takes place in saturated hydrocarbons. Saturated hydrocarbons undergo substitution reactions. The simplest example is substitution of halogens in methane CH4. Here 4 hydrogens are there, and it reacts with chlorine Cl2. Chlorine is having 2 chlorine atoms. This reaction takes place in presence of sunlight. Here this reaction is very simple. Here 4 hydrogens are there, no? One of these hydrogens is replaced by 1 chlorine. That means you just bring 1 chlorine here and remove hydrogen. That means chlorine, hydrogen, you just interchange their places, then you will get CH3. Since we have reduced 1 hydrogen here, it becomes CH3, and when we have substituted 1 chlorine, so it becomes CH3Cl. And this hydrogen which is coming out from methane combines with the leftover chlorine here. 1 more chlorine will be left now, and it becomes HCl, hydrochloric acid, hydrogen chloride. That's all, very simple. Generally substitution reactions take place in sunlight. So these are the 4 different types of chemical properties or chemical reactions of hydrocarbons. So in this video we have discussed combustion reactions, oxidation reactions, addition reactions and substitution reactions. I hope you understood these concepts clearly. Be healthy and be happy. Thank you for watching. We'll meet in the next video.